Hello everyone, welcome to Explore Hop. So for this example, we're told that in a class of 30 students, all students enjoy at least one of the following two subjects, math and English. 15 students enjoy math and 20 students enjoy English. 15 students who enjoy English don't enjoy math. Then we let A be the event that a student enjoys math and B be the event that a student enjoys English. Are A and B mutually exclusive? So let's first start by constructing a Venn diagram to help us organize all the information that we're given. Now, after we've drawn a Venn diagram, we'll label the regions math and English. So we'll label the region on the left, math, and the region on the right, English. We can see from the question that 15 students who enjoy English don't enjoy math. From here, we can determine the number of students who enjoy both math and English. Since we know that 15 students who enjoy English don't enjoy math, then the remaining students who enjoy English also enjoy math. So we'll write down 5 in the middle. And this of course means that 15 minus 5, which is equal to 10 students, enjoy math but not English. So we'll write down 10 in the leftmost region. So now from the Venn diagram, we can determine the probabilities of event A, B, and the intersection of A and B, as well as the union of the two events. So we have that the probability of event A, which is the probability that a student enjoys math, is equal to the total number of students who enjoy math divided by the total number of students in the class. Likewise, to find the probability of event B, which is the probability that a student enjoys English, take the total number of students who enjoy English and divide it by the total number of students in the class. And we can see from the Venn diagram that the probability of the intersection of event A and B, which is the probability that a student enjoys both math and English, is equal to 5 over 30, which is equal to 1 over 6. Now, right away, we can immediately see that since the probability of the intersection of event A and B is not equal to 0, then this means that events A and B are not mutually exclusive. However, we can still go ahead and calculate the probability of the union of events A and B. So the probability of the union of A and B is just equal to the probability of event A plus the probability of event B minus the probability of the intersection of event A and B, which is just equal to 1/2 plus 2 over 3 minus 1 over 6, which is equal to 3 over 6 plus 4 over 6 minus 1 over 6, which is equal to 6 over 6, which is just equal to 1. And from here, we can clearly see that the probability of the union of event A and B is not equal to the probability of A plus the probability of B, since 1 over 2 plus 2 over 3 is not equal to 1. And this, of course, confirms that A and B are not mutually exclusive. So therefore, events A and B are not mutually exclusive. And that's it for this example. Thank you for joining us. See you in the next lesson.